Hello, am I audible? Can anyone confirm? Hello. Hello, am I audible?
Yep.
Okay. Thank you. Is my screen visible?
Yep, sir.
Okay. So, good afternoon, everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. My name is Awan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So, this is my second live session for this course. So in this live session we will mostly discuss some practice problems related to week 3 because week 3 is running in this course right now. So we will solve some practice problems on week 3 content, and then I will also try to answer your questions and queries, and if you have any other doubts you can ask me after that. So first we will discuss some practice problems. Okay, so this is the first question. So in week 3 there are three topics like linear classification, then logistic regression, and then LDA, linear discriminant analysis. So these are the three topics. So I will discuss some problems on these three topics today. So this is the first question. For linear classification there are four options: a linear function to separate the classes, a linear function to model the data, a linear loss function, a non-linear function to fit the data. So these are the four options. What do we use for linear regression? We use only one of these four things. So what is that? Kebal Krishna Singh, week 2 we already discussed in the previous session only, because in the previous session we discussed some problems from week 1 and some problems from week 2, and this is the third week, right? It is the third week of this course, right?
I answer present. Good afternoon. It's Keval here.
Yes.
Sir, as earlier also I have joined the session on
Yes.
the previous week.
Yeah.
So, but as I remember that there is only discussion of week 1 modules. It is not for the week 2.
No, I
You haven't discussed.
discussed week 2 modules, I think. I discussed about PCA and other things. I discussed last year in the last session. So all those topics come under week 2.
Okay.
Linear regression and PCA, these come, and also this subset selection, all those are covered in week 2. I already discussed in, because this is the week 3, right? This is the week 3 of this course, right?
Yes.
Yeah, that's why I'm discussing week 3 practice problems, so that it will help you to solve the week 3 assignments, because week 3 assignment you have to submit in few days. So that's why previous session I already covered week 1 and week 2, because in the first week of this course there was no live session. Live session started from 4th February, which was the second week of this course. So that's why I covered week 1 and week 2 in the previous week only. So I'm covering week 3 here. So which of these four options should be right for linear regression? Which of these functions do we use for linear regression? Linear classification. Some of you have already written A in the chat, which is a linear function to separate the classes. So the correct answer is A here. We use linear function to separate the classes. We do not try to model the data. The data can have a different kind of underlying distribution or function that represents the data. So we are not trying to model the data, we are trying to separate two classes with straight lines. So we are using linear functions to separate classes, and also we are not using non-linear loss. We are using mean squared error, which is not a linear loss function, and we are also not using non-linear function to fit the data. So A is the right answer. We are using a linear function to separate the classes. So A is the right answer. Now this is the second question. Which of the following loss functions do we use to best fit the data in logistic regression? So which of these loss functions we use for training in logistic regression? There are four options: Manhattan distance, negative log likelihood, Jaccard distance, and none of the above. So logistic regression has already been taught in the week 3. So this is present in week 3 module. So in logistic regression, which loss function we use? So there are some answers in the chat. B is the answer. Some of you have written. So the loss function that we use is negative log likelihood we use. If you go through the lecture, you will find that we are using log likelihood of all the data points that training data points that we have. So because of log we actually do multiplication of the probability values. Because of log it becomes summation. So the answer here is negative log likelihood we use, which looks something like this. Summation I equals 1 to n yi log p xi plus 1 minus yi log 1 minus p xi. So this is the loss function that we use, and yeah, I think there is a minus before this. So this is the loss function that we use, negative log likelihood, and we try to take the find out the derivative of it, and in every iteration we update the coefficients based on that. So B is the right answer, negative log likelihood. Manhattan distance, Jaccard distance, we don't use these error functions, at least in logistic regression. So B, logistic regression, would be the correct answer. Anyone has any doubts on this? Yes.
So when to use the Jaccard distance?
No, I mean you can design any kind of error function for different learning algorithms. So I don't right now remember any algorithm where Jaccard distance is used, but in many of the algorithms different loss functions you can try. Like here negative log likelihood is generally used in linear regression, logistic regression, but in linear regression we use mean squared error. Instead of mean squared error we could have used Manhattan distance also. In linear regression it can be used.
It is I understood the Manhattan distance and the negative log likelihood as in the linear regression we can use,
Yeah,
but I wanted to know about the Jaccard distance, what it is.
I don't exactly remember anywhere it is used at all or not, but I just put it as an option just to test. I think I don't think it is used in any
But in
learning
KNN
algorithm.
also, we use the Manhattan distance only.
Now in KNN we use Euclidean distance. In Manhattan the square term is not there.
Yeah, it is.
Manhattan is the city block distance, like the square is not present there. In Euclidean, in KNN we use Euclidean, which has this x1 minus x2 square plus y1 minus y2 whole square. So this square term is present in Euclidean. So Jaccard, I don't know if it is used in any language. You can find it in the internet, but I just put it as an option only. So B is the right answer, negative log likelihood. So let's come to the third problem. The output of binary class logistic regression lies in this range. There are four options. Which range is correct? Minus infinity to infinity, minus 1 to 1, 0 to 1, minus infinity to 0. So Keval and Sapna have written C, which is 0 comma 1. Any other answers? Okay, so no other answer. So C is the right answer here. Two of you have already written it in the chat, which is 0 comma 1. So in logistic regression we use this sigmoid function, which is written as the sigma of z, which is equal to 1 divided by 1 plus e to the power minus z. So this is how we define this sigmoid function. So because of this sigmoid function, if you plot this sigmoid function, you will observe that its value ranges from 0 to 1 like this. So this is the curve. Sorry, this is the sigma curve. So the value ranges from 0 to 1, and we need this thing because in logistic regression we need to restrict the output within a given range, otherwise we will not be able to select a certain class for the output. But in linear regression we don't apply any such sigmoid functions or any such functions, because the output is continuous. It can be anything from minus infinity to infinity. But in case of logistic regression, which is a classification algorithm, we need to restrict the output between 0 to 1, so that we can find out whether it's 0, or if it is more than half, then we call it 0. If it is if it is more than half, we call it 1. If it is less than half, we call it 0. So there are two classes, 0 and 1. So that's why we use sigmoid function in logistic regression, and the output of sigmoid function is bounded between 0 to 1. So Cable has written, determine the class will be hard to determine if we will not have the constants. Yeah, that is the thing. In case of linear regression, we don't have any such functions applied on the output. It is just the combination of the summation of the multiplication of coefficients and the input features. But in case of logistic regression, we have to restrict the data within a given range, otherwise we will not be able to determine the class. That is the right interpretation of it. So C is the right answer, as I've already told. So this is question 4. Logistic regression is robust to outliers. Why? So there are 4 reasons given. Which one of these 4 is correct? The squashing of output values between 0, 1 dampens the effect of outliers. Linear models are robust to outliers. Third option is the parameters are logistic regression. The parameters of in logistic regression tend to make small values, tend to take small values due to the nature of the problem setting, and hence outliers get translated to the same range as the other samples. And D is the given statement itself is false, which is that logistic regression is robust to outliers. This given statement itself is false. That is the option D. So which of these 4 is true here? Is the actual reason behind this robustness to outliers? Many of you have written C here. The parameters in logistic regression tend to take small values due to the nature of the problem setting, and hence outliers get translated to the same range as other samples. Parameters in logistic regression tend to take small values, but is this true? It is not always true that parameters would be taking small values, because we make it small by using the sigmoid function. It can be anything like plus 1000, and we apply sigmoid function on that, and then it comes between 0 to 1. So the parameter value can be anything. The parameter values can be from minus infinity to infinity. So the correct answer is Muhammad Shahid has written A. Anand Kumar has also written A. Cable has written A. Yeah. A is the actual reason, but that we are applying the sigmoid function, so that's why some, even if some outliers or noise points are present, still I mean the effect of those points would become much smaller because of the application of the sigmoid function, and the output range is 0 to 1 only because of that. So the effect of the outliers become much smaller in this case. And C, yes, Keval.
Sir, it must be, I think so, it should be multiple choice answer, and A and C both could be the correct, because in the logistic regression there can be a problem of both the issue, as the question doesn't have any syntax that it shall not be in a appropriate part. The C option has been already registering that the parameters in the logistic regression tend to take small values. It is in the function, and due to the nature of the nature of the problem is not been discussed in the question. So the nature of the problem can be assumed anything, and setting hence outlier get be translated to sample as other samples, and it can hamper the range.
No, C
Basically,
is,
we tend to fix the outliers because of the sample size only. Means to fixing the samples only to some ranges, isn't it?
yeah, I mean, but C is not exactly correct. Parameter values can take any value from minus infinity to infinity. I mean, if we only apply regularizer, I think you have read about regularizers, L2 norm, L1
Yeah,
norm
I have
regularizers.
read about
Yeah, if
regularizers,
you
but sir,
apply those
what
regularizers, then only parameter values would be closer to zero. Otherwise, parameter values can be anything.
without taking regularizations also, if we will get into the data points, if the data points have the data limits of minus infinity to the infinity size, and we are getting to the class, then it will impact the data. If there is like for an example, there is two columns, age and class.
Yes.
There is a class size and there is an age of the class size, and if we will go with a data point, and if there is one data point between the any age that is hampering the data, then we can correct the data, and then we will have to correct the data as an imputed values. If we will not, then it will hamper the class size,
No, I
that
mean, but
particular.
how is this parameter value tend to take small values is related to that? I mean, it can have, the age column can have any value, that can be a noisy value, but the effect of the out, that thing dampens
Noise will
because
be
of
always
that.
noise will be always there. The function itself defines the noise. Noise will be also there. We are defining the logistic regression as f of x is equal to beta naught plus beta 1 x plus noise term only. So noise will be always there. Noise cannot
No,
be ignored.
I can't understand your logic here, but I think A will be the right answer here, and I think you
I'm not
should
asking. I'm not
consult
asking the
with internet and search about it. But what I understand, it should be A, that the output value is ranged between 0 to 1. That's why the effect of the outlier becomes much smaller than it is in other classifiers, other regression algorithms. In case of linear regression, the value can be very high, and so it is not ranged between 0 to 1, so that's why the effect is much higher in that case, but in this case it becomes smaller because of this sigmoid function that we use.
So just a simple question over here, that if the outlier will be present in the data,
Yes.
we are not considering any parametric values. If there will be any outlier in the data, will it impact the variance and the bias?
Yeah, I mean the variance can be high in that case. I mean even bias can also be high in case of error. If you are not able to predict it properly, then bias might also be very
then
high.
we will get then we will getting the trade-off between that.
Yeah,
We
but
will have to take.
no, I mean of the option C is not right. Why I am calling it is not right? Because the parameter values can take.
Now might you have understood what I am telling?
I am also not able to understand what you are telling. I am telling that C, the parameters in logistic regression tend to take small values. This is not right. This is not at all right that parameters can take small values. Parameters can take any value. We are using sigmoid function to so that we scale it down to 0 to 1. That is what I am trying to say. The C option itself, I mean, it tend to take small values only if we use regularizers. Otherwise, why would parameters try to take smaller values? Parameters can take any kind of value. So that's why I'm saying that C option is not right here. And A is clearly one of the reasons. It can be many other reasons that it is
A is the
why.
correct answer. I am not telling. I am not arguing with the answer, sir. A is a correct answer that I know. A is itself defining that it is a correct answer, but getting C not to be the correct, that is the issue over here. Okay, sir. I will search on that.
Yeah, yeah, you can search that why it is robust outlast, and there can be many other reasons, but I think C is not right because it can take smaller values, which is not right. I mean, even it is just like linear regression with only just application of the sigmoid function. Just to scale it down to 0 to 1. So in linear regression also the coefficients can take any value from minus infinity to infinity, and only if we use regularizers then only the parameters can take small values. So you can read more about it, not a problem. But what I understand is A is the right answer, that because of the uh, squashing of the output values between 0 to 1, it dampens the effect of the outliers. Any other doubt in this? So this is the question 5. Aim of LDA is multiple options may be correct. LDA is linear discriminant analysis, which is part of week 3 content. Aim of LDA is minimize intra-class variability, maximize intra-class variability, minimize the distance between the mean of classes, maximize the distance between mean of classes. So what is the actual objective in LDA? So LDA can be used both for classification and also for feature reduction. We can use LDA for reducing the number of features as well, and also there is dimensionality reduction, and we can also use it for classification. So which of these following which of these 4 options is or are correct? Yeah, multiple options may be correct. Two of you have written A and D. Any other answers? So in LDA, so A and D are the correct answer here. So in LDA, what we try to do is that we try to maximize the distance between the means of the classes. So if consider this is one set of class, this is one class set of points positive, and this is a set of points which are all negative. So we try to maximize the distance between its means. So its mean can be this is the mean for this class and this is the mean for this class. So we want to maximize the distance between the these two means, and we try to project it on a straight line or projection line or vector where this distance would be the highest. If we project it on this line, then this is one center, this is another center, this is the distance. And if we project it on this line, this is one center, this is one center. So this way we try to find out in on which projection line this distance is maximized between the means. And then there is another objective, which is we also try to maximize the intra-class variance. Minimize the intra-class variance. So this is one class, this is another class. So we try to minimize the intra-class variance also, so that all the points within a given class is very much close to each other. So these are the two objectives of LDA: minimize intra-class variability and maximize the distance between the classes. I think all of you have seen the objective function in LDA, which is something like this. If we try to find the vector W, which is the projecting vector W, this divided by this plus this. So this numerator is the distance between the means of the two classes. M1 bar is the mean of one class, M2 bar is the mean of the second class, and this is the distance between the two classes. We want to maximize this JW with respect to W. We want to maximize this numerator, and these two terms in the denominator, this is the variance. This is the variance of class 1 and this is the variance of class 2. So I am showing it only for two classes. So this is the total variance of the data, total the summation of all the intra-class variances, and this is this numerator is this one, the distance between the means. So if we maximize this JW, so this numerator is maximized, the denominator is minimized, and so we are maximizing the distance between the mean of the classes, and we are minimizing the intra-class variability or the inter-class variance. So A and D, these two are the right answers here. Saurabh Biswas has written B and D. B cannot be right. Maximizing inter-class variability is not the objective. We want all the points in a given class to be very close to each other. So intra-class variance should be smaller and the intra-class variance of the means should be higher. This is our objective in LDA. So B should not be right, A should be right, that minimizing the intra-class variability and maximizing the distance between the mean of the classes. Any other doubts in this, in LDA? This is the next question. This is again on LDA. We have two classes in our dataset with mean 0 and 1 and variance 2 and 3. These are the four options. LDA may be able to classify them perfectly. LDA will definitely be able to classify them perfectly. LDA will definitely not be able to classify them perfectly. None of the above. So two classes are given, and we are using the mean for the first class is 0, mean for the second class is 1, variance for the first class is 2, variance for the second class is 3. So now if this is the dataset that I have for the two classes, which of these four is or are correct? That will LDA be able to classify them perfectly, or will it not be able to perfectly classify? So keep in mind that LDA can only linearly classify the data, that if the data is linearly separable, then only LDA will be able to perfectly classify the data, because LDA creates a linear discriminant or a linear a straight line between the two classes to separate the two classes. So The mean and variance values of the two classes are given. So what should be the right answer? Keval and Sapna have written A. Muhammad Shahid has written C. So LDA may be able to classify them perfectly. This is A, and C is LDA will definitely not be able to classify them perfectly. Saurabh Biswas has written C. Any other answers? A and C are the two answers that I have got so far from the chat. Anyone else? A and C has been proposed in the chat. So A is LDA may be able to classify them, and C is LDA will definitely not be able to classify them. So if we draw the data set, so the mean for class first class is 0, mean for second class is 1. So these are the two means, and variance is 2. So variance is 2. So variance is a square term, so we should take the standard deviation, which is square root of 2. So square root of 2 is at around 1.4, and square root of 3 is around 1.7 or something. So the first class, how would the first class look like if we draw the contour of that? So it has a variance of 1.4. so this is 0 and this is 1. If the variance is 1.4, so it would be something like this. The contour of that data set might look like this. This is the class 1, this is 1, so it would cross the 0.1 because the standard deviation is 1.4. so this would be class 1. And if we draw the second class, class 2, which is centered at 1 and with a variance of 3, which is standard deviation of 1.7, so it would be something like this. This would be class 2, isn't it? These are the two classes, how it would look graphically, isn't it? Is there any doubt in this graph? So I have used the mean values for the two classes 0 and 1, and the variances are given, but we want to work with standard deviation obviously, because variance is squared of the error that we get. So it's 1.4 for the first class and 1.7 for the second class. So it is certainly more than 1, which is the distance between the two means. Whatever it is, 1.4 and 1.7, it is more than the distance between the two classes, two means of the two different classes. So if we draw the contour of the two classes, the two classes are certainly overlapping. Keval has written explain the graph. So this is what I am explaining, that we are given the means and variances. Mean is 0 for the first class and mean is 1 for the second class. So the variance is 2, so it would look something like this, isn't it? This first circle that I have drawn. Is there any doubt that this can be the pictorial description of the class 1? Similarly, for class 2, the mean is 1 and variance is 3, so standard deviation is almost 1.7. So this would look like the second circle that I have drawn, centered at 1. So the certainly the points are the circles are overlapping, isn't it? Is there any doubt in this drawing?
For a class 1, we are taking centered at 0.
Yeah, I mean the mean value is 0, and the
Hmm.
for the class 1, and the mean value is 1 for the second class, and the variance is 2. So the variance is 2, so standard deviation is 1.4 around. So there are some points beyond 1 also for the class 1 only, which is centered at 0, isn't it?
That will be the outliers, might be.
Yeah, so some points might be there can be some points here even for the class 1, the first class, because the standard deviation itself is exceeding the mean of the second class. So there can be some points here, and similarly for the second class, there can be some points here. Here there can be also some points here, because the variance is 3, which is certainly not less than 1. So some points of class 1 is falling within
Sir, how we
the
can depict with the variance that the class means the class data points are outside or inside the
so
class?
variance is given 2, so that means standard deviation is 1.4, and we know that the number of points that lie between uh, mu minus sigma to mu plus sigma in this range, 68% of the points lie between these two range for any uh, normal distribution or even any other
Yes,
distributions.
yes, sir.
And if we multiply it by 3, if we take the minus 3 sigma to plus 3 sigma range, then it becomes 99.7% of the points lie between this
Yes,
range. And I'm just considering this mu plus sigma and mu minus sigma. 3 we can also consider, then also it is much more clear. Even if we consider mu plus sigma, mu minus sigma range, so 68% of the points, so majority of the points should be between this range. So that is what I'm considering. So from 0 to this, 0 to this, that is mu plus sigma, this is mu plus sigma point, this one, and this is mu minus sigma point for the first class. Is it right?
yes, yes.
So
Understood,
so
understood.
some points would be here where I have drawn those red crosses, so which is certainly within the range of the second class only. And similarly for the second class,
Sir,
uh,
there is one question
hmm?
which, sir, there is one question which is coming in mind,
Yes.
that is it necessary that the data point will cover the normal distribution or the Gauss distribution?
Yeah, I mean it might not be no, I mean the mean variance values are given, so it might not be Gaussian. It might be any distribution, but the variance is 2. I mean variance is 2 means, so standard deviation is 1.4. So
This
some points
formula
are
which
there
we
in
Sir, this
1.4.
formula which we are taking mu minus sigma and mu plus sigma, mu minus 3 sigma plus mu plus 3 sigma.
Hmm.
Sir, it generally depicts within the normal distribution.
Yeah, it is for the normal
So
distribution
as
for, yeah.
distribution of the data as the data points are not with us. So considering normal distribution
even
and taking
even if we don't consider it as a normal, it can be any distribution. Even in that case, standard deviation is 1.4. So that means there are some points at around 1.4, less than 1.4, and possibly more than 1.4, isn't it? Standard deviation is 1.4. That means the mean error that we get in the data is 1.4. So some points would be lesser than 1.4, some points would be greater than 1.4, isn't it?
okay, understood, understood.
So the standard deviation is 1.4, means some points are situated at greater than 1.4. So that means which comes under the range of class 2 only. Even if it is not a Gaussian, then also from the standard deviation we can say that the two classes are overlapping, because the distance between the two means is 1 only. So if the standard deviation is 1.4, it is crossing the that distance between the two classes, so it has to overlap.
Sir, what exactly mean when the classes are overlapped?
No, I mean mean is the mean for that class only. The all the points belonging to the class
Yeah,
1,
the
we
meaning.
take the mean of that.
What is the meaning of the overlapping of the classes? What actually it
Some
means?
points, I mean the two classes are not completely linearly separable. Some points of class 1 is present among some points of class 2. This is like what I have drawn here is that some points of class 1 and some points of class 2 are overlapping with each other, so it is not linearly separable.
Understood.
Any other doubt in this, anyone?
Sir, in the question 5, which we have seen the formula in the question 5,
Yes.
that is m2 minus m1 by subtractions of the variance.
Yeah,
This is the formula only, maximum.
yeah, this is there in the video lectures also. So
Yeah, yeah. I haven't gone through with the week 3 modules yet, so I'm just. So,
yeah,
sir,
this is there in the LDA part.
yeah, yeah. Sir, while considering this formula, we can solve that question.
This question 5.
Yeah, just considering this formula.
Yeah, so this formula tells that the objective of L, this is the objective function of LDA, J of W. So we are trying to find out the W that maximizes this JW function. So here the numerator is m1 bar minus m2 bar whole square. So m1 bar is the mean of the first class, m2 bar is the mean of the second class, and this is the distance between the two means and square of that. This is the numerator. So this is the which is in the option D, maximize the distance between the mean of the classes, which is the numerator. And in the denominator, so delta 1 square plus delta 2 square. So delta 1 is the variance of the class 1. So all the points in the all the points that are present in the class 1, we take the variance of that, and all the points that are present in the class 2, we take the variance of that. That becomes delta 2 square, and we add all those intra-class variances. These are intra-class variance because we take the variance only within that class, and then we sum all of them and put it in the denominator. So if we maximize JW, numerator is maximized and the denominator is minimized. So this distance between the means is maximized, and the total variance of the intra-class, the sum of the intra-class variances is minimized, which is in the denominator. So that's why if you remember this formula, you can find out the answers that minimize the intra-class variability and maximize the distance between the mean of the classes. If you go through the LDA part, there are 3 videos on LDA, I think you will be able to understand.
Hello, sir.
Yes.
Good afternoon.
Yes.
I was having a training in college, so I joined late. So, is it possible to give the recording?
Yeah, I am recording this session, and I will have to submit the link to NPTEL, so they might later send all of you the links for these sessions. There are 4 different sessions that are running every week, so all of us have to submit the links, and I think NPTEL would later send all these links to all of you. So this is a 2-hour session, but first hour is almost over, so I have to create a new Google link because Google Meet doesn't allow meetings over 1 hour. So I'm creating a new meeting link and sharing it in the chat. I've shared the new meeting link in the chat. Make sure that you click the link first and then leave this meeting, otherwise you lose this chat. So all of you please join the new meeting. This meeting will be over in 5 to 10 minutes because Google doesn't allow more than 1 hour. So everyone please go to that meeting. I will end this meeting in few minutes, and I will join that meeting and let all of you in that new meeting. Those who joined late, first hour of this live session is done, and we have to create a new meeting link because Google doesn't allow meetings for more than 1 hour. So I have pasted a new meeting link in the chat. Please copy that meeting link and go to that meeting and leave this meeting. The next 1 hour will be conducted in the new meeting link. I can see there are still 11-12 students present in this meeting. Please go to that meeting. I will end this meeting and join that one in a few minutes. Am I audible?
Yes, sir.
Okay, thank you. Okay, so we can start the second hour. The question 6 I already discussed. So using the graphical representation of the two classes, how we can tell whether LDA will be able to classify them or not. So C is the right answer. LDA will definitely not be able to classify the two classes perfectly. So it will give a linear function that will that can be used as a discriminator, but that will not be perfect. Some errors would be there. So this is what I'm trying to say. 7, a very similar question. You have two classes in our dataset with mean 0 and 5 and variance 1 and 2. So now what will be the the answer here, whether LDO will be able to classify or not perfectly. So may be able to classify perfectly, will definitely be able to classify properly, and will definitely not be able to classify them perfectly, and none of the above. These are the four options. Means are 0 and 5, and variances are 1 and 2. I can see some answers in the chat already. Some of you have written A, some of you have written B. Saurabh, Swapna and Asha has written A. Muhammad Shahid has written B. So will it be may be able to classify, or will it be will definitely be able to classify? Vinod and Keval have written B, which is LDO will definitely be able to classify them perfectly. So no one has written C, that definitely not be able to classify them perfectly. So any other answers in the chat? Does anyone think C would be the correct answer? Will definitely not be able to classify? Kaustubh Rai has also written B. Cable has written, as the classes are not overlapped as per the diagram using mu minus sigma, we can also see the data classes at different level. So if we draw the data, so this is mean 0, this is mean 1, and variance of 1, so this would sorry, it would be 5. So let's say here it would be somewhere here, and the so this is the class 1 and this is the class 2. So most of you have written B here, that will definitely be able to classify them perfectly, and some of you have also written A, that may be able to classify them perfectly. So it is standard deviation or variance is 1, which is standard deviation is also 1, means that it is the average of the deviations from the mean that I am getting. It is not that all the points will lie within that only. Some point for the class 1 might even lie here, maybe only 1 point, but it can still lie here, isn't it? So if the so this is red cross, this is a point for class 1 only, but it is present so far away from class 1, it is actually nearer to the second class. This can be a scenario, isn't it, that some of the points, some of the outlier points we can say, might lie very far away from the mean, but the standard variance we will get 1, because most of the points are nearer to the mean 0. So there can be such scenarios, and similarly for the second class also we can have some points which might lie here, very few points, but there can be 1 or 2 points or some more points that might lie closer to class 1, but those are actually points for class 2. So we are working with variance, not the exact boundary that all the points lie within. Variance or the standard deviation means the average error that we get, average deviation that we get from the mean. Some points might lie outside the variance range. So here the right answer should be may be able to classify them perfectly. that we may be able to classify them properly. If such outliers, so those green and red points that I have drawn, those are not present, then it is very much possible we can just draw we can have such a linear function that will discriminate these two classes. And if such the outliers or noise points are present, then we will not be able to classify. So definitely be able to classify this will not be right answer. A will be the right answer, that it may be able to classify them perfectly. So it depends upon how is the distribution of the actual data. So the actual data point, if the actual data points are given, then only we will be able to say that whether LDA will certainly be able to classify them or not. But from the data that we are given, mean and variance values, we can say that it may be able to classify, it may not be able to classify. So B option, many of you have written, but B will not be right. Is there any confusion in this, that why it is not B? Yeah, so you have to be careful that though the variance or the standard deviation is very small, some outlier points might be present far away from the actual mean. Very few points, but still those points are present in class 1 only, but they are very far away from the class 1. So because of them, the LDA will not be able to perfectly classify. It will be able to classify, not perfectly. Yeah, so A is the right answer. Depends on the actual data points. So we need to have the actual data points, then only we will be able to say whether there are any points which are actually nearer to class 2, which actually belong to class 1 or not. So outliers are there or not, we will not be able to find out if we are not given the data points. So that's why A will be the right answer here. Okay, so this is question 8. So a plot is given. There are two classes. You can see these plus points, which are all these points belong to class plus, and there are minus points. So all these points belong to class minus. So there are two classes you can clearly see in the plot. And so question is, while performing LDA on it, which line is the most appropriate for projecting the data points? So I have already told that LDA is used for both classification and dimensionality reduction or feature reduction. So similar to PCA, it tries to find out those projection lines on which the data points can be projected with two objectives that I already discussed. The two objectives of LDA, which is the two objectives of LDA is so it's maximizing the distance between means and minimizing the intra-class variances of different classes. So these are the two objectives. So if we even if we consider only the first objective, that maximize the distance between the means of the two classes, then using only the first objective we can find out which of these four will be the correct answer. Red, orange, blue, green, which of these four lines represent the appropriate projecting line? Sapna has Keval have written C, which is blue. Yeah, blue is this line. So will it be blue or any other straight lines? Any other answers? Saurav has written A, which is red. red is this one. Kaustav has written B. B is orange. And there are 3 different answers that I'm getting from the chat. So will it be blue, orange, or red? Is there anyone who thinks green would be the right answer? Yes, so we are not talking about the classifier or the separating line that we get from LDA. What I am talking about here is that if we try, LDA is also used for feature reduction. Similar to PCA, we try to find out the directions along which, if we plot the data, it is better for the classification in future. So it is not about the classifier. So we are not talking about the classifier here. We are talking about the projection line. If we project all the points on that straight line, then it's better to represent using that projected data. So the projected data is better than the actual data points while classification. LDA is also used for that. Usha has written D, so we got all 4 options from the chat. This is the green. So the if we think about the objectives here, if we only think about the first objective, that is enough here in this case. If you have followed the LDA lecture, sir has already shown that W, which is the direction of projection line, it is represented as a vector. It is proportional to m2 bar minus m1 bar. So m2 bar minus m1, the m2 bar is the mean of the second class and m1 bar is the mean of the first class. So first we need to see where are those m2 bar and m1 bar lie. So m2 bar is somewhere here. Sorry, this can be m1 bar, and this is m2 bar. So this red straight line that I have drawn, this is the m2 bar minus m1 bar. This is this red line joining the 2 centers of the 2 classes. This is the m2 bar minus m1 bar. This is the vector that represents m2 bar minus m1 bar, and W, which is the direction of the projection line, should be proportional to m2 bar minus m1 bar. And if you check all the 4 straight lines, only the blue one, this blue one is parallel to this line. So proportional in case of vectors, proportional basically means parallel. Even in case of straight lines, proportional means parallel. So there is only one straight line which is parallel to the to this red joining line that I have drawn, which is this blue line. So from this we can see that if we project this data, if we project the means here, this is one mean, this is another mean. Here the distance between these 2 projected means is highest, and you can check with other 3 straight lines, this distance is not the maximum. The distance is maximized only in this blue projection line. So that's why this blue would be the right answer here. So we project, select the projection lines in such a way that the distance between the means, the projected means, is maximized. Keval has written, in simple words, we can consider that the vector within the same direction can be projected within the same plane. I didn't understand, Keval, what you have written.
Sir, it is a property of a vector that a vector, if it is the resultant vector or the given vector, the vectors can be represented within the same plane and
Hmm.
projected within its parallel anywhere in the given plane.
Yeah, yeah, yeah. Hmm.
It is a property. So I am just writing that line.
Yeah, this
That
is this is
W
what
is
I'm.
equal to M. That if we are taking and considering the mean, we can project any parallel side.
Yeah, this is this proportional here in case of vector is just like
Yes.
parallel.
Yes.
So W is should be parallel to this vector m2 bar minus m1 bar. So m2 bar minus m1 bar is the joining vector, and any line parallel to that would be the projection line. So in this
Yes.
case, only the blue line is the parallel one.
Yes. That only
Hmm.
I want to express.
Yes.
It is easy to understand.
Yeah.
Thank you, sir.
Anyone else has any other doubt in this? So I got all four answers from the chat, but please try to understand that blue should be the one because it maximizes the distance between the two means, and this is one of the main objectives of LDA. The second objective we don't have to think about it much in this problem. Uh, so based on the first objective, this should be the right answer.
Sir, might I want to
Yeah.
argue? I want to present one argument.
Yes.
As my peers have classified orange line and one more was the red. So might the peers have an issue with the understanding of the projection and the classification?
Yeah. I mean, this is
So
what I also
because
told that.
as I have seen the comment, so I am just put it the means my words that orange can be the classifier as I think
Yeah.
because they are might be they are not from the same background, so they might have an issue of understanding between the
Hmm.
classification and the projection.
Yeah, I already
So,
told in the beginning of this question that LDA can be used for both the cases, that we might want to use it for classification and we can also use it for feature reduction. So in case of feature reduction, we try to find out the projection lines that we might project the data onto that line, so that the number of dimensions we can reduce. And in this problem we are not talking about the classifier line. So if you are talking about the classifier, then the orange one would have been the classifier, but we are not talking about the classifier. We are talking about the projection direction along which if we project the data, then it becomes easier for representing the data for any classifier to classify. So we are not classifying the data in this case, we are projecting the data, so that we can reduce the number of dimensions, and reducing the dimension means it's easier to work with that data. So here the objective is to project the data on a straight on a given direction, not classifying it. So orange would not be the right answer in this case.
Sir,
and sir, a request will be there.
Yes.
A request will be that could you
green
please
green
explain
can
the
be
yeah, Usha, you can. Sorry.
green can be the project. We can project the data points in the green line now, sir.
No, I mean, if you project it on green, if you can just visually see that if we project the 2 points here, these are the two projections it would be, but the
This
distance.
negative
Yeah.
in the mean you could have placed in some other also, no? Here also we can place. Why you have choose this point?
Now mean of positive class. Where will the mean of positive class be? In the center of all the positive points.
This negative.
And
This
in case of
negative.
negative, the mean would be at the center of all the negative points. So this is the mean of class 1, this is the mean positive, and this is the mean negative, isn't it? So mean positive should be here where I have written this m plus, isn't it? All these points are positive here, these are all positive points, and these are all negative points, isn't it? So
Sir, whenever we have the gathered data now, we take the centered point as a mean because within the center there are lots of data. So we consider that it is a mean and we take a differentiate. And if we will go with the mathematically, then we take as a theta. What is the theta between the so the theta will be the projection basically. So if we will
Okay.
considering the theta, then theta of the blue line and the red line which sir has made is actually equal or proportionately equal. So that is the actual projection line.
Yeah, so you can just visually see that you, if you project these two means on the green line, the distance between these two projected means is not as much as if we project it on the blue line. If we project it on blue line, then it is the highest. We can easily see that.
Okay, thank you.
Ayan sir,
Yes.
I was interrupted in between.
Hmm.
Sir, I would request you to that please consider a minute to take LDA with a classification. How LDA will help to take this classification within this problem only.
If you build a classifier, then classifier would be somewhere around this orange line, this
No,
one.
how within the LDA it will, so
No, I mean, then you have to study earlier from the video lecture for week 3. Then otherwise it will take a lot of time. LDA, there are 3 videos in LDA in that, each of them around 15-20 minutes. So it's a big topic.
okay, okay.
So you can go through that. It's not very difficult. So any classifier, if we build using LDA, it would be somewhere around this orange line only, because this is the one that separates these two classes. So here we are not talking about the classifier. So if we build classifier, it would be somewhere near to this orange line only.
Okay.
Yeah, so blue is the correct answer. So the reason is that the blue line is parallel to the line joining the mean of the clusters and will therefore maximize the distance between the means. So that is the reason. So 9th question again on LDA. LDA assumes that the class data is distributed as Poisson, uniform, Gaussian. LDA makes no such assumption. LDA assumes that the class data is distributed as. Does LDA assume anything about the underlying distribution of the data? Some of you have written C, some of you have written D. C is Gaussian and D is LDA makes no such assumption. So in LDA itself doesn't assume anything about the underlying distribution for the data. D should be here the right answer. We can use Gaussian, or we can use any kind of data that we think that might be better for that data. We can use that. LDA is a generic algorithm. You can use any kind of distribution that you want for that. So LDA itself doesn't make any such assumption. Generally we give the examples during the teaching LDA by using Gaussian, but Gaussian it is just we are taking it as an example, but LDA itself doesn't make any such assumptions. You can use other, even Gaussian is there, and then so sir has written in the lecture only that Gaussian is possible. Non-parametric assumptions are also done, that non-parametric probability distributions are also considered, even naive Bayes. So many of you have already, I think, know this name, naive Bayes is also one of those methods. So and some other underlying distributions can also be considered. So am I audible? Hello?
Yes, sir.
Yeah.
Audible.
Yeah, so what I was talking is that while so many of you have written C, which is Gaussian, but that is not right. LDA doesn't assume any such thing. During teaching, LDA Gaussian is used just to make things easier to understand, but you can use any kind of underlying probability distribution for LDA. So D will be the right answer. 10th question. This is on logistic regression. Yeah, I mean, this is on normal classification. What would be the ideal complexity of the curve which can be used for separating the two classes shown in the image below? So ideal complexity of the curve that can be used to separate these two classes. So you can view that these are one class and all these points are another class. So two classes are present. So what is the ideal complexity? Linear, quadratic, cube, and insufficient data to draw conclusion. Many of you have written A and one of you have written D. So Robert has written D. D is insufficient data to draw conclusion. So all the points, the level points are shown in the plot, and we can see that there is one outlier. This is one outlier point or noisy point. But if we just remove that point, if we don't consider that point, this is a very easy classifier to build. This is a straight line that will classify almost all the points except this outlier point, this blue dot among these triangles. So A, linear, should be the right answer. So we can consider this blue dot as an outlier or noisy point. Just because of this point we cannot draw a much more complex classifier. That is not needed for just one point. A simple linear classifier is more than able to solve to separate these two classes. So this option 1 would be right, linear. Any doubt in this, that linear would be the right answer here? Yeah, so linear is the right answer. So it's a very simple question. We have to just consider this blue dot as an outlier point. We don't have to consider it as some special point. Then we have to draw a much more complex curve to perfectly classify even this point. That is not required. We can just classify all other points perfectly using this linear separator. So linear is the right answer. So this is 11th question. This is the last question. So this is a basic mathematics question. This has not much to do with the logistic regression or LDA that we are talking about in this session. So this is given log of 1 minus px by 1 plus px equals beta 0 plus beta x. So this is one kind of formulation that we do in case of logistic regression. That's why it has been given here. So what is px? B has been proposed in the chat. So B is this one. D has also been written in the chat, which is this one. D. So if we calculate it, so if we if we remove this log, so it would be e to the power beta 0 plus beta x, then 1 minus px equals e to the power beta 0 beta x plus px into e to the power beta 0 beta x. From here, so px, if we take it as common, it would be 1 plus e to the power beta 0 plus beta x equals 1 minus e to the power beta 0 plus beta x. So px is 1 minus e to the power beta 0 plus beta x divided by 1 plus e to the power beta 0 plus beta x. So this is the option D. Option D would be the right answer. 1 minus e to the power beta 0 plus beta x divided by 1 plus e to the power beta 0 plus beta x. So yeah, so D should be the right answer. This is not a very difficult question. You can just do normal arithmetic and you will get the answer. Yeah, so here the answer is given. This is how you solve it. I've already written in the previous slide. So this is the answer. So yeah, these are the questions that I wanted to discuss today on week 3 content. So now, if does anyone have any doubts on this? Any doubts in the questions that I solved today in this session, or even any other doubts regarding the content of this week, week 3? Any book for fundamentals? The books are already recommended by the instructor of this course. You can find the names there in the course web page only. There are, I think, 1 or 2 books have been recommended.
Sir,
Yes.
how to find a covariance matrix for LDA?
How to?
How to find the covariance matrix for LDA?
So
That's one of the questions in the assignment.
So covariance matrix for LDA, normally if the data given is the data matrix is X, then the covariance is X transpose X divided by n minus 1. N is the number of data points. This is how you compute the covariance matrix for a given set of data points. And in case of LDA, where exactly are you looking for covariance in LDA?
Like if we are applying LDA to a binary set binary data and we are asked the covariance matrix of the same.
Yeah, so normal covariance matrix is computed like this. You can also find it in the internet. This is standard, that X is the your data matrix, that is it is a n cross D matrix. So n is the number of data points and D is the number of features. Then the covariance matrix can be computed like this: X transpose X divided by n minus 1. So the covariance becomes a D cross D matrix. So D is the number of features.
But if the output has 2 labels, then also will this formula hold?
Yeah, this doesn't have anything to do the outputs. I mean, output is Y. We are not considering Y in case of covariance. This is the covariance matrix for the whole data, whatever is the output for any data point. So sigma is only dependent on the X. This is the covariance of the features, input features. So sigma doesn't depend on Y. The normal covariance that we compute, this is only dependent on the input features.
Okay. I will try to. Thank you.
Okay. Anyone else? Any other doubts in this?
So could you outline Ridge and Lasso regression?
Which regression?
Ridge and Lasso.
Regional. So that was the last week.
Yeah, but I have some doubts on that.
Yeah. So the normal, the how it differs from the linear regression is that in ridge regression you use another. So you want the coefficient values to be as close as possible to zero in case of ridge. So that's why you apply the L2 norm regularizer there. And similarly in lasso, how it differs from the linear regression, the objective remains almost same, except that you use the L1 norm regularizer with the objective function. So these are the major differences from the normal linear regression. If you go through the lectures, then you will find that these are the main differences. In ridge uh, we want these beta values, the coefficient values, as close as possible to 0. That's why we use the L2 norm, that is summation of beta I square, I equals 1 to d whatever. So that we want, that we add as the L2 norm regularizer. And similarly in lasso we don't add those squared terms, we add those absolute values of those coefficients, and we want those also as close as possible to 0. That's why. Any other doubts or questions?
It means that in a ridge regression, we will considering that the output should be nearest to the 0 point in a ridge.
Yeah, in no, not output, the coefficient values we want very small. We want the coefficient values to be as close as possible to 0.
Zero.
Yeah, as close as possible to 0, but I mean it also, the objective has two parts: the actual the mean squared error plus that regularizer. But you will obviously put more emphasis on the mean squared error than the regularizer. If you put more emphasis on the regularizer, then all the values would be set to 0. Then you will not get any classify a regression model at all the coefficient would be 0. So you add that as an extra objective with that. And then the extra one parameter is used, lambda, which you can control based on how much regularizer you want. Any other questions? Those who have any doubts, you can stay in the meeting. Those who don't have any other doubts, you can leave. Mohammad Shahid is asking, does other sessions have same questions? It might be same questions, it might not be same questions. Some questions might be same, and some questions might be different. So if you want, you can join other sessions also. So there are 4 sessions, you can join as many sessions as you want. So there are 2 sessions coming up today only. After that, from 5 to 7 and 7 to 9 another one. So you can join any sessions you want.
Hello, sir.
Yes.
Sir, can we practice it online? LDA and regressions all?
Practice it online means what practice? Programming it or what?
Yes, programming and this all whatever you have explained it.
Yeah, you can read it online. Obviously, there are many resources present in the internet. You can read from it, and also the books that sir has recommended. And obviously, first you have to see the video lectures. Then you can
Yeah.
consult other sources. Also, not a problem. And also you can mm, code it if you want. So not a problem there.
Okay. Okay. Thank you.
I will wait for a few more minutes if anyone has any other things to ask.
Sir, in lasso also we have the objective to take the coefficient nearest to the zero.
Yeah, the objective is same, just how we use the regularizer is different. So there we are taking the summation of beta squares. Here we are taking summation of absolute value of the betas. So we
That is
take
the
the
beta means L1 norm and L2 norm only.
yeah, so in lasso we
This
use
is
L1 norm, in ridge we use L2 norm. So these are the two differences. Otherwise the main thing remains the same.
okay. Okay. Thank you. Could you little bit explain about forward step wise and forward stage wise?
Yeah, so forward these are the two different subset selection methods for feature reduction. So in forward stepwise, this is a greedy method. So in every step or every iteration, you try to add one more feature to the feature set that you already have from the previous step, and try to see whether it is improving the result or not, whether it is improving the result significantly or not, how much significantly you want based on that. So this is normal greedy method. First you check one, then you add another feature, then you add another feature, whether it is improving or not, that way. But this is straightforward, but in stage wise it is a little bit different. So in every iteration you already have a set of features that you have got from the previous few steps, and then you compute the residual based on those features. So you have to compute the residual, and you have to find out a new feature from the features that you have not considered yet. A new feature which has highest correlation with the residual. So you are fitting a new feature on the residual and checking which new feature has highest correlation coefficient with correlation with the residual, and you add that feature again. So in every stage, I mean every step in stage wise uh, forward stage wise selection, you do one univariate linear regression, that you have this residual and you try to pick the feature which has the highest correlation with that.
Okay. Okay. Thank you, sir.
Okay.
Is any blog written by you or anything where we can see?
No, I don't have anything, but these methods are standard methods. You can find many other sources. Also, the book has been recommended by sir, so you can go
So you
through.
are researching on machine learning only.
Yeah.
May I know what is your objective of the project?
My research topic is on transportation field and application of machine learning, deep learning, reinforcement learning on vehicle routing problems and transportation problems based on that.
Okay. Okay. There is one more. Your project is going in IITB also, I think so. Transportation routing.
Yeah, no, not my project. I mean that kind of project.
Routing.
Yeah.
Sir, hello.
Yes.
Sir, who can provide us recording of today's session?
I have to give those links to NPTEL, and after that, I think NPTEL would be able to send these links to all of you.
So by today it will be shared, sir.
That I don't know whether NPTEL will share today or in the coming week. I'm not sure. But we are recording these sessions, and we have to give those links to
Yes,
NPTEL.
sir, it will be very helpful because our academics was going on, no, sir. So we joined late, and also previous sessions we have missed out. So please, I request to share these recordings. Whoever have.
Yeah, I mean these sessions are recorded, and NPTEL will collect all the links from all the TAs, and they will uh, uh, give those links to all of you later. I think so. I don't know when they will give, but they might give later. But this is why there are four sessions running.
Okay,
Um,
so all the sessions are having same questions. Today we have
No,
only.
no. Some questions might be similar, some questions might be different, some might discuss some other kind of thing. So, all four sessions, it is not certain that all of us will be discussing the same thing. So,
That's why I'm
different things
confused.
might also be there, some things might also be same. So, you can attend any session. Four sessions are going on in every week.
Okay, okay, sir. Cable, sir. Hello, hello,
Hello.
hello. Cable, sir. You have posted a message that you can create a WhatsApp group. So,
Your
can you?
voice is too low, unable to hear you. Could you be a little bit louder?
Oh, yes, sir. Am audible?
Yeah, yeah, Runa, you are.
Sir, you have written a message, no? You can create a WhatsApp group for us so that it will be helpful in the assignment purpose.
Yeah, 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 it is. I
So,
am just your
yes,
POs, not a server. So you can elaborate as a cable only. You people can create a group. I can ping my number over here. So if you
okay,
people are required for, as I am not that much experience in machine learning, currently I am also doing the same.
okay, sir.
I
So
have
there
posted
is,
my number.
I hope all
Yes,
of
yes.
you know about the discussion forum. This is a Google group
Yeah, yeah,
for
yes,
this.
yes.
So
Following that also.
yeah, you can post your questions and get your doubts cleared there also. The regular TAs for this course would try to answer your question. Even we also visit sometimes the group and try to answer if some doubts are there regarding our sessions. So you can use that Google groups for discussion among students, also with the TAs.
Mayan sir, are you on LinkedIn? Sorry for being professional.
Yeah, I have a LinkedIn profile.
Okay.
So thank you everyone. If there are no more questions or doubts, then we can end this meeting.
Yes, sir.
Thank you for joining
Have a nice
everyone.
day.
Thank you, sir.